Everyone. Now my topic is about dynamic programming. Dynamic programming is a general algorithm design techniques for solving problems defined by or formulated as recurrences with overlapping sub-instances. It is invented by the Richard Bellman in the 1950s to solve the optimization problem. The main idea of dynamic programming is to set up a recurrence relating a solution to larger instances to solution of smaller instances. It also works based on the principle of divide and conquer. It is used to solve smaller instances once. It is used to record solutions in the table, and it is used to extract the solution to the initial instance from the table. It is applicable when subproblems are not independent. Subproblems share the subproblems. For example, nk is equal to n minus 1. It is splitted into n minus 1 k plus n minus 1 by k minus 1. A divide and conquer approach would repeatedly solve the common subproblem, whereas the dynamics problem solves every subproblem just once and store it as a answer in the table. Used for optimization problem. A set of choices must be made to get an optimal solution, and from this choice find the solution with optimal value, that means either minimum or maximum. There may be many solutions that lead to an optimal value. Our goal is to find an optimal solution. For example, for a given problem, a set of choice can be made by the user or a programmer, whereas then he or she needs to find the solution with optimal value. There may be many solutions that lead to an optimal value. At last, our final goal is to find an optimal solution. Dynamic programming algorithm characterize the structure of optimal solution. How you are performing that solution is can be characterized. Recursively define the value of an optimal solution. While calculating the solution for a subproblem, it is stored in the table, whereas for again if we want to calculate the solution for the same set of values, it is not calculated again, whereas it is taken from the table value where it is stored. Compute the value of an optimal solution in a bottom up fashion, means from the leaf node to root node, the values are calculated. Construct an optimal solution from computed information. An algorithm design method can be used when the solution to a problem may be viewed as the result of a sequence of decisions. The dynamic programming algorithms store the results or solutions for small subproblems and looks them up rather than computing them and leads later large solver problems. In divide and conquer rule, while the large problem is divided into subproblems and we need to calculate solution for each and every problem, where there is no storage concept in divide and conquer, whereas in dynamic programming language a solution is divided into subproblems. While calculating the solution for each subproblem, the result is maintained in the form of a table, and while again calculating the solution for the problem for the given set of values, it retrieves the value from the stored table. Here the time is consumed and it is very efficient. Typically applied to optimization problem, either to calculate the minimal solution or maximum solution. Principle of optimality. An optimality sequence of decisions has the property that whatever the instance state a decision are, the remaining decisions must constitute optimal decision sequence with regard to state resulting from the first decision. Essentially, this principle states that the optimal solution for a larger problem contains an optimal solution for a smaller problem. Here, the optimal solution for a large subproblem contains the optimal solution for the smaller problems, as the large problem is divided into smaller subproblems. Dynamic programming versus greedy method. What is meant by greedy method? Only one decision sequence is ever generated. Greedy method means at the time of instance of solving a problem, we need to choose only one decision. Whereas coming to dynamic programming, many decisions can be taken while solving a problem. Divide and conquer versus dynamic programming. In divide and conquer, as we earlier discussed that in divide and conquer, every problem is divided into subproblems, where each and every subproblem for each and every subproblem the solution need to be calculated, whereas in dynamic programming a large problem is divided into subproblems where the solution of a subproblem is maintained in the form of a table, while again calculating the solution for the subproblem containing the same values, then the values or the calculated value will be retrieved from the storage table for the time efficiency. Knapsack problem. In a knapsack problem or rucksack problem, we are given an n items where each item is specified I and value vi. I also given size bound, the size of our knapsack. What is knapsack problem? Coming to a glance that a thief breaks into a museum. Fabulous paintings, sculptures, jewels are everywhere in the museum. The thief has a good eye for the value of these objects. So, and knows that each will fetch hundreds, thousands of dollars in the Candlestein art collector market. But the thief has only brought a single knapsack to the scene of robbery, whereas here knapsack means a bag with a minimal amount of storage or with a proper or optimum storage. And can we take, he can't take all the things. So by the calculation of how much he made profit through those jewels, he can make those objects into his knapsack. So what items should he choose is the question for our knapsack problem. Knapsack problem are divided into two types: 0 by 1 knapsack problem, fractional knapsack problem. Whereas 0 by 1 knapsack problem deals with that while placing each and every item in the bag, if the weight exceeds while placing an item into the bag, then there is no chance to keep that item into the bag. Whereas in fractional knapsack problem, while placing an item into a bag, then there is no space. Then a part of the item is placed into the bag. Here we are given n objects and a knapsack. Object I has a weight Wi and knapsack has a capacity M. If the fraction xi of object is placed into the knapsack, then PIXI can be earned. That means a part of the profit only earned, not total amount of profit. The objective is to obtain a filling of knapsack which maximizes the total profit earned. Here the given formula is maximize sigma I less than or equal to I less than or equal to n PIXI subject to sigma 1 less than or equal to I less than or equal to n WIXI, which is less than or equal to m. Greedy algorithm gives the optimal solution for the fractional knapsack problem. And also here we came to another concept, that the edit distance problem. It is also called as string addition problem. Here there are three string operations which are needed to be performed. Those are insertion, deletion, replacement. For example, string A is winter, string B is writer. Here V I T E R W R I T E R S. M is equal to match, I is equal to insert, D is equal to delete, R is equal to replace. The edit distance can be calculated. The edit distance between two strings. The permitted edit operations, what are we discussed earlier? Insertion, deletion, replacement. Definition: a string over an alphabet IDRM that describes a transformation of one string to another is called edit transcript, or a transcript for short of two strings. Here RIMD MDMMI means R means replace, I means insert, M means matched, D means delete. So we can convert those strings. Coming to VW, then R means it should be replaced. V should be replaced with W. Next I means insert. Here R is not there. So we need to insert R value. Next coming to II. Here it is matched. D. N. N should be deleted because it is not consisted in writers. M. It is matched. For N it should be deleted as N is not there in string B. E and E, those are matched. R and R, those are matched. S, it should be inserted. The edit distance between two strings. Definition. The edit distance between two strings is defined as the minimum number of edit operations like insert, delete, replace, substitute needed to be performed on the first string in order to obtain the second string. For emphasis, note that matches are not counted. Here matches should not be counted, whereas the edit operations like insert, delete and replace should be counted, and it should be done in minimum number of iterations. String alignment. A global alignment of two strings S1 and S2 is obtained by first inserting chosen spaces or dashes either into at the ends of S1 or S2, then placing the two resultant strings one above the other so that every character or space in either string is opposite a unique character or a unique space in another string. Thank you.